Hello, this is Mr. Kinyanola, and I'm going to help you derive the law of sines. First word here is deriving. Derive, not driving, but deriving. Deriving just means using knowledge that we already know to get new knowledge. So we're going to derive the law of sines. Now, this isn't regular sine where it's opposite or hypotenuse. It's the law of sines. The law of sines helps us find angles and sides for a triangle that isn't a right triangle. Remember, regular sine in our calculator only works when it's a right triangle. But the law of sines works when it's not a right triangle. I drew a random triangle here. I don't know if it's a right triangle. It looks obtuse to me, but we'll never know because I don't have a protractor and I don't want to measure it. But we're going to derive this new law called the law of sines. All right, so in order to derive the law of sines, it's based off regular sine. In regular sine, you need a right triangle. So in this non-right triangle, I'm going to split it up so that we'd have two right triangles. I'm going to take my gray pen and I'm going to draw a line that is perpendicular to this base. So I'm going to draw this right here, and hopefully it's perpendicular. If not, we'll just pretend it's perpendicular. That looks pretty good. And so because it's perpendicular to this base, I'm going to put that 90 right there. And I'm going to call it h, little h, for the height. If we were finding the area of this triangle, this would be the height, this would be the base, perpendicular. What I did there was I created two right triangles so we can use regular sine, not law of sines. So let's focus on this triangle right here. We have this angle right here, angle A, and I want to use regular sine. Remember, sine is opposite over hypotenuse. So I want to find the sine of A. I want to set up the sine of A. So sine of angle A is equal to its opposite, which is h, over the hypotenuse of just this triangle, which is B. Yeah? Okay, so we focus on this left triangle right here, and I wanted to find the sine of the angle of this triangle. So the sine is the opposite, which is h, over its hypotenuse, because this is also a right angle. Let's put that right angle there. Right angle, B. Okay? And I'm going to look at our other right triangle, and I want to find the sine of the other angle there, which is B. I can't find the sine of angle C because this is split up, and C is split up into two angles now. But I want to focus on just this triangle and find the sine of B. So the sine of angle B is equal to the opposite, which is h, over the hypotenuse, which is A. All right, so there we go. We have two proportions right here, and I want to put a 1 under here, and I want to put a 1 under here. And let's look at both of these. They both have something in common. They have, don't say A, because we have angle A and we have side A. Lowercase a is side, uppercase A is angle. Don't say B because we have lowercase b, which is side B, and we have uppercase B, which is the angle. But they both have side H right there. Okay, and what I want to do is I'm going to focus on this one. I'm going to get H by itself because both of them have H. So we're going to cross multiply. 1 times H is equal to side B times sine of angle A. I'm going to do the same thing over here. 1 times H is equal to side A times the sine of angle B. All right. What do we do just right there? We got both H's by themselves, and both H's are talking about this same H right here. So what can we do? We can do this thing called the transitive property. Transitive property says if B times sine of A is equal to H, and H is equal to A sine of B, then b times sine of a has to equal a times sine of b. It just means both of these equal h, so both of these have to be equal to each other. Or if you want to think of another way, we can substitute. H is equal to b sine of a, so I can substitute this into this h because it's the same thing. So b times sine of a is equal to a times sine of b. We substituted this h with b sine of a because b sine of a is equal to h. So both of these have to be equal to each other. Hope that made sense. If not, then rewind it. Okay. Next thing is, we have lowercase b, we have uppercase b, we have lowercase a, and we have uppercase a. I want to get these two, the uppercase and the lowercases together. I want to get the lowercase, uppercase b's together. So let's work on, first thing, let's work on the b's. I want to bring this b to the other side. This b is multiplying sine of a, so the opposite of multiplication is division. And what do? These b's cancel out, and we're left with sine of angle A is equal to A times sine of angle B over side B. Now I want to get this A to the other side to join the uppercase A. So this A is multiplying sine of angle B, so the opposite of multiplying is dividing. So I'm going to divide this side by A and divide the other side by A. Now these a's cancel out, and now lowercase a is with uppercase angle A. And so let's simplify that. So sine of A, angle A, over side A is equal to the sine of angle B over B. This right here is the law of sines. Now, if you look at it, you're like, what? We did all that for this? I don't even get, I don't, what? Huh? What? Huh? Well, let's look at our original diagram. What did we just do here? We made a proportion. We took, here's angle A. And what's lowercase a? It's the side that is opposite to that. So if we can set up a proportion where the angle, the sine of an angle over its side, opposite side, right here, the sine of an angle over its opposite side is equal to the sine of an angle and its opposite side. Huh! And you could do that you could do the same thing. Doesn't matter, just as long as, here, look at C. So the sine of C is over its opposite side, C. So all three, so the sine of angle A over its opposite side is equal to the sine of B over its opposite side. And you could even say that it also equals the sine of C over its opposite side, C. Okay, so this right here will help us find angles and sides for triangles that aren't necessarily right triangles. This would work for right triangles, but it also works for triangles that aren't right triangles. So we just derived the law of sines. Well, let's also add sine of C over C. So that also works too. So any of these three work, but all you need is two of them. So two of them to equal each other. So you could do that, you could do that, you could do that. So that's how you derive the law of sines.